Well, hi guys, welcome back. So today our topic is Casey. So and our target is 15 questions. Sorry, at least 30 questions we have to complete. Minimum is 15. Yeah, let's start. And if you like the video, I'm just started my YouTube channel in a weeks ago. So I want you to encourage me. I'll support you with the questions more and more. I'll make more questions which helpful to you for your examination for your NEET score. So make sure to like, share and subscribe to my channel so you'll get the notification as I post any video in further. Okay, so today's topic is only about the Kc. Okay, Kc. The first question in this concept: what is the equation for equilibrium constant Kc? I'm sorry, I forgot to tell you that Kc stands for equilibrium constant. Okay, what is the equation for equilibrium constant for the following reaction? So they gave us a reaction, A gaseous of mole of A gaseous plus 1 by 3 moles of B gas gives to 2 by 3 moles of C gas. So we have to write the equation for this reaction. Remember, whenever it's given like for example, it's like X moles of A is given. So whenever we are writing equilibrium constant for them, we have to write like A to the power of X. And one thing, whenever we are writing the Kc, first in the top we have to write the products and in the bottom we have to write the reactants. Okay, so let's apply these rules here and see. So as per us, first we have to write the products on the top, right? So let's write a line, and on the top we have to write the product. Here the product is a C. Okay, so first write the C, and what are the here the exponential for the C is 2 by 3. Yeah, we have to write like this: C to the power 2 by 3, and in the denominator we have to write, we can interchange the A and B, there is no much changes. Here it comes like A to the power of 1 by 2, next B to the power of 1 by 3, and here is the answer for our question, and the option matches for 2 by 3, 1 by 2 and 1 by 3. So the option is 3. Well, our next question is our question number 2. The equilibrium constant for the given reaction N2 plus O2 giving rise to NO2 is 100. Okay, let's underline the numericals given and the information provided in the question so we can answer the question easily. Yeah, they given the Kc value is 100 for a reaction. What is the equilibrium constant for the reaction, and the given another reaction? So they are by providing this they are asking about this reaction and the Kc for this reaction. First basic concept, remember, whenever for example a reaction A giving rise to B has a Kc value something, while we are reversing the reaction the Kc value will be 1 by Kc. While we are making the reaction reverse, the Kc will be 1 by Kc. And while we are dividing the reaction with by 2, meanwhile we are taking off moles of everything, we are dividing the reaction with 2, so we have to write root Kc. Do you know why we write the root Kc? It's Kc power 1 by 2, right? And 1 by 2 can be written as root 2. I'm sorry, 1 by 2 can be written as root, like so, like this. And when we are reversing and making half the reaction, 1 by 2, and we have to take root over Kc. Hope you understand what I'm saying. We are taking the Kc into the denominator, we have 1 and root Kc. Okay, so let's try to answer this question. Yeah, I have written the options here. They are given us 100, initial Kc value is 100 for the top reaction, and we can observe here the reaction is reversed. See, the NO2 here is in the reactants, but the given in the given reaction provided in the question, the NO2 is product. So as it reverse, we have to write the 100 in the denominator. Meanwhile, it's like 1 by 100. And next, here you can see 1 mole of N2 is there, and here half mole of N2 is there, and here 2 moles of O2, and here is only 1 mole of O2. 2 moles of NO2, only 1 mole of NO2. Meanwhile, they divided the top reaction with 2. So we have 1 by 2, 2 to cancel here 1, and 2 to cancel here 1. So we have to take root over 100. So it's like 1 by root over 100 is 10. So the answer is that one, 0 0.1. 1 by 10 equals to 0 0.1, right? So yeah. And our next question here, the equilibrium constant for gaseous reaction N2 plus O2 giving rise to 2 moles of NO is 4 into 10 to the power of minus 4. Underline this. Now Kc for the given another reaction. Based on this reaction, we have to answer this. Yeah. First, let's see what are the changes they have done. Here, NO is in the product, and here NO is in the reactant. So we have to divide the Kc with 1 by Kc. Next, we have to take the Kc in the denominator. Next, here 2 moles of NO, but here only single mole, and here 1 mole, here half mole. Next, here 1 mole, and here half mole. Meanwhile, they have divided the equation with 2. So we have to take root over Kc. So the answer will be like now 1 by, here the Kc value they given 4 into 10 to the power of minus 3. So I am substituting here 1 by root over 4 into 10 to the power of minus 4. So it becomes root over 4 is 1 by 2 into 10 to the power of minus 2. So it's like, it's like 100 by 2. The answer will be 50. Sorry, I forgot to write the options here. Here the option is 2.5 into 10 to the power of minus 2. Option B is 50, and option C is X, and option D is Y. Well, we don't need to mind that. So option B, we have 50. Hope you understand. If you don't understand, just see the video again, so you'll get. Well, our next question is, if the equilibrium concentration of each component is 0.2 m, correct order for Kc of the given three reactions. So the given the concentration of each component in the reaction, so they are asking what is the value of Kc for them. So in order to find the Kc, we have to write like Kc equals to concentration of product by concentration of reactant. Okay, so we have to find out like this. So let's take the first one. It's like as I in the previous video I said, we have to take the one for solids and liquids. We have to take the constant active mass for the solids and liquids as one. Okay, let me change the color, it's not clearly visible, I hope. Yeah, if we write for the first one, and the products is two gases, so concentration of, in place of initial I'm taking 0.2 because they already said it's a concentration of each component. So 0.2 into 0.2, here H2S gas, so 0.2 by 1. So here it goes like 4 into 10 to the power of minus 2. And next second one, gas, and HI is also gas, so 0.2 into 0.2 by, here 2 moles of HI, so 0.2 into 0.2 cancels, so second one is equals to 1. Third one, here it's gas form. So here the product 0.2 into 0.2 by reactant 0.2, so it cancels 1. So the order will be now, this one is the least one, so 1, greater than 3, greater than 2. Yeah. Our next question, for the equilibrium Kp, here the given the Kp. Well, Kc we are taking for the gaseous reactions and Kp we are taking for the, sorry, both the Kc and Kp are taken for the gaseous reactions, but when they are mentioning about the concentration, we take it as Kc, and where when they are mentioning the values in the atmosphere, meanwhile in the pressure, we are taking it as Kp. Okay, both are the equilibrium constants itself. So okay, see for the question, for the equilibrium constant Kp in the atmosphere C, so it's a Kp 300 Kelvin. What is Kc? So we have to take here a small relation between the Kc and the Kp. So it's like Kp equals to Kc to RT or delta N. This is an important formula in order to find the relation between the Kc and the Kp, and here the delta N stands for number of gaseous moles of products minus number of gaseous moles of reactants. Delta N stands for number of moles of gaseous products minus number of moles of gaseous reactants. So here delta N stands like that. Yeah. Okay. So here the given the Kp is like Kp is given 0.82 equals to, we have to find the Kc, so I'm writing it as x and R value. We have to learn the R values, like when it's given in the atmosphere, we have to take R value as 0.08 liter atmosphere, and temperature they have mentioned into 300 kelvins, and delta N. So delta N is like all these are gases they didn't mention in the question, but we have when they're not mentioning in the question, we can take it as gaseous forms. So 2, 1 plus 1, 2 minus 1, so it's 1, so delta N equals to 1. So here it can be written as 0.82 equals to x into, zeros get cancelled, so 8 into 3, 0.82 equals to 24x, so x equals to 0.82 by 24, so it's nearer to 0.03. I just calculated by pausing the video. Okay, so it's like 0.03. That's it. Well, our next question, a mixture of 2 moles of N2 and 8 moles of H2 are heated in 2-liter vessel till equilibrium established. At equilibrium 0. moles of N2 is present, then H2 will be at equilibrium. Okay, uh, yeah, we are going to do this. First let's write the equation. Whenever they are mentioning something, if we know the equation better, we write it. Okay, yeah, here is the equation. N2 plus 3 moles of H2 gives 2 moles of NH3. There are two ways to find out. I'm gonna say you the simple way, so we can do it, make it easy. We need to find the best ways to answer easily and early in the examination, right? So here initially 8 moles of H2 are taken, so value of H2 at initial stage is 8. At equilibrium it's 0.4. Okay, at equilibrium it's 0.4. Next, I'm sorry, what is, okay, I'm sorry. Initially N2 is 2 moles and 8 moles of H2 is taken. Yep. And at the equilibrium 0.4 moles of N2 is present. Okay, let's do like this. If 2 moles are completed to 0.4 moles, then 8 moles will be X value. So it's like 2x equals to 8 into 10 to the power of minus 1. So x equals to 1.6. Here we go. Yeah. Yes, our next question is the equilibrium constant for the reaction H2 plus I2 gives rise to 2 moles of HI is 2. So here the given the value of Kc at certain temperature, the equilibrium concentration of both H2 and HI are 2 moles. What would be the I2? Meanwhile, initially, okay, they already participated the reaction at a certain time. The Kc of the reaction is 2. Okay, I hope it's visible clearly. Yeah, at certain time the Kc of reaction is 2, and at the other time now they are asking, they have given the situation 1 is Kc is 2, and as we know the Kc is constant at any instant. So this is the instant one, and at the instant 2 they given the concentrations of H2 and Hi, and they are asking the what is the concentration of I2. Okay, yeah, we're gonna find the concentration of iodine now. As you know, the constant Kc for a reaction is constant, so we can take Kc equals to 2. So like Kc equals to concentration of product by concentration of reactant. Hope you guys remember this. Yep. So it goes like the products are Hi. Okay, so the given the concentration for Hi is 2. So Hi and the preposition for Hi is 2. So 2 square, yes, by the given the value for H2 is 2. We're gonna find the value for I2 equals to 2. As the Kc is constant, Kc equals to, and we substitute the values. So here we find out like 2 equal to 4 by 2x. So x equals to 1. So the concentration of the ion equals to 1 at certain temperature. Well, here our next question is, a mixture of 0.3 mole of H2 and 0.3 mole of I2 is allowed to react in a 10-liter vessel at 500 degrees Celsius if Kc of H2 plus I2 giving rise to 2Hi is 64, the amount of unreacted I2 at equilibrium. Well, up to now they asked us about the what is the quantity that reacted and what is the quantity form, but now they have given some values and asking at equilibrium what is the quantity of something which is unreacted there. Okay, so let me tell you how to find this. Okay, first let's write the basic equation so that will help us. Yep. Well, this is the basic equation provided for us. Yes, initially 0.3 moles of H2 and 0.3 moles of I2 is taken. So let's write 0.3 moles and 0.3 moles. It's initially, so I'm indicating with I, and it's initially it's 0 because the reaction is not started at, and it's 0. Now at the at equilibrium, it's like 0.3 minus x, 0.3 minus x, and it gives rise to 2x. Yes, here 2 moles, so I written 2x here. Next, I have given the value of Kc and initial moles. Based on this, we're gonna find out how much of the I2 is unreacted at the equilibrium now. So first let's know the value of x. So we can say by removing the x from the 0.3, we get the thing which is unreacted. Meanwhile, still it is in the form of I2, which is not formed yet, has 2Hi. If we minus 0.3, if we minus the value of x from 0.3, we will find which how much quantity of I2 is left over. So given for Kc value is given, so let's do like this. 64 equals to Well, we are using like Kc equals to product by reactants, right? Like that. Here 2x by 2x whole square. Here the coefficient 2 is there, right? So square 0.3 minus x whole square, because 2 is there, so I'm taking as whole square. And we can write 64 as 8 square. Squares get cancelled, so it's like 2x equals to 2.4 minus 8x, and it goes like 10x equals to 2.4. So the x value will be 0.24. So what we got now, the amount of HI which is reacted, meanwhile which is formed as 2I, we find the values, but asking unreacted one. So if we remove this from the 0.3, we get that. So 0.3 minus 0.24, so we get 0.06. This is our answer, and the option is D. Well, our next question is 1 mole of A is heated to 300 degrees Celsius in a closed 1 liter vessel till the following equilibrium is reached. So the equation is like A and B. A gives rise to B and B gives back A. The equilibrium constant of the reaction at 300 degrees Celsius is 4. So the Kc value is given for us. What is the concentration of B at equilibrium? Okay, let's write the equation. Initially 1 mole of A is taken, so 1 initial one. At the equilibrium it's 0 initial, right? So 1 minus x and here x, so the Kc value is given, so 4 equals to, so the Kc value is given for us, so it's 4. And as you know, Kc product by reactant, right? So the product is x, so x by 1 minus x. So we're gonna find out the value of x, because what is the concentration of B at the equilibrium? At equilibrium the concentration of B is x, okay? So it's like 4 minus 4x equals to x. So 4x equals to 4 equals to 5x and x equals to 0.8. So the answer is C. Well, our next question, this is a bit good one, right? Okay. At a given temperature, Kc is 4 for the reaction H2 plus CO2 gives rise to H2O plus CO. Initially 0.6 moles of H2 and CO2, let's underline the values, and CO2 are taken in 1 liter flask. Okay, it's 1 liter flask. The equilibrium concentration of H2O, so they are asking, well, let's write the equation down here so it's clear for us. H2 plus CO2 plus CO, right? All are the gases, so I'm not mentioning here. So one thing, if x is got minus from here, x is formed here and here, so the both values will be same. So let's find both together and divided by 2, so we'll get the answer of 1, because they are asking only the value of H2O, not the CO, right? So has amount disappeared from here is same amount distributed between them, so it's equal between them. Okay, so okay, let's do this. So it initially 0.6 0.6 and initial values of this are 0, because the equation is not started at, reaction is not started at, and at the equilibrium it goes like 0.6 minus x, 0.6 minus x, and x. Okay, so the Kc value is given for us, okay, 4. So let's do same like previous one. 4 equals to, here product 1 means well x square, 2 x's are there, so x square by 0.6 minus x whole square, same values over here, right? So like this, same, if you write 4 as a 2x square, squares get cancelled. So x equals to 1.2 minus 2x. So 3x equals to 1.2. So x equals to 0.2 by 3. It's like 0.4. And our answer is 0.4. So the answer is 0.4. I'm sorry I didn't see the camera. It's just... Well, our next question, this is a different one. Meanwhile, just in the same process, slight changes, right? Initially, 0.8 mole of PCl5 and 0.2 mole of PCl3 are mixed in 1 liter vessel at equilibrium. Okay, 1 liter vessel. At equilibrium, 0. Mole of PCl3 is present. The value of Kc for the reaction. Okay, let's write down the equation first. It's like PCl5, PCl3 plus PCl2, right? I'm sorry, PCl2. It's 2. Okay, initially we are taken 0.8 moles of this and 0.2 moles of this, and this is a 0 initially, indicating with I. Well, now at equilibrium, it's like 0.8 minus x, 0.2 plus x. Initially we have taken 0.2 moles of PCl3, so we have to indicate it here even, and it's only x. Now they are asking the value of Kc for the reaction, so let's do the same process. So the Kc equals to x 0.2 plus x by 0.8 minus x. Well, it's gonna be like hold on, sorry, the given at equilibrium 0.4 mole of PCl3 is present, right? So we can find the value of x here itself. We are not gonna do this. So here the value of this is given at the equilibrium stage is 0.4. So 0.2 plus x equals to 0.4. So x value will be 0.2. So substitute the x values here and we get the answer now. So it's Kc equals to, here the value of this is 0.4 given in the question, into 0.2 by 0.8 minus 0.2 is 0.6. So after this we get like Kc equals to 8 into 10 to the power of minus 2 by 6 into 10 to the power of minus 1. So here it goes. Here it's minus 1. 8 by 6 into 10 to the power of minus 1. So it's like 0.13 mole liter inverse. Well, here is our next question. Initially 0.8 moles of PCl5 and 0.2 mole of PCl3. I'm sorry, this is a previous one. It seems like question is doubled here. Well, okay, this is the new type of question. It's a tricky one. We don't need to solve this one. Like whenever the question is given like this, they have given 3 reactions and they're asking about the 4th reaction. So in this time, just a simple trick is just multiply all of this. Yeah, hold on, I'm going to write the options for this. First one is 48, the second one is 624, and the fourth one is 12. Yeah, so just multiply this and we're gonna get the answer. So 4 to 8 and 8 3 is 24. Answer this. Simple. Well, our next question is here. For the reaction A plus B giving rise to C plus D, the initial concentration of A and B are equal. Okay, this question is like in terms. They didn't give you the exact values, but they given in terms. Meanwhile, the value of C is given in terms of A. like that. Okay, well, A and B are equal. The equilibrium concentration of C is of the initial concentration of A. Well, let's write down the equation first. A plus B giving rise to C plus D. I'm gonna take a simple equations, simple numericals for this. So let me take the two. Well, the side initially A and B are equal, so I'm gonna take 2 and 2, so it's zeros. Next, the equilibrium concentration of C is half the initial concentration of A. So C is concentration half of the initial concentration of A. So if we divide, if we of the two, we get 1. So these both will be same. So it's 1. So the amount which is disappeared will be appear here. Meanwhile, if one is appeared, one is disappeared from here. So 2 minus 1 is 1, and here also 1. So Kc at this will be 1 into 1 by 1 into 1, so answer is 1. Simple. It's 2 minus 1, 2 minus 1, so 1 1. Well, here is our next question. This is a bit interesting one. A plus 3b gives rise to 4c. Initial concentration of A is equal to initial concentration of B, same like previous one. And next, the equilibrium concentration of A and C are equal. Now the Kc value. So let's write down the equation first, so it makes very easy. Next, now initially t equal to 0. Meanwhile, initial time equal to 0. So here A and A. Meanwhile, the same value, both are the same values, right? So like that, and it's 0. And at the equilibrium, A minus x, A minus 3x. So it's 3. So I written 3x. Here 4x is formed. So the given A minus x, meanwhile at the equilibrium concentration of A and C are equal, means this and this is equal. So I'm gonna write like this: A minus x equal to 4x. So A value will be 5x. I'm gonna substitute here 5x minus x, 5x minus 3x, and here 4x. So here will be 4x, here is 2x and 4x. So the Kc now will be 4x power 4 by 2x power cube. Next 4x, and here it goes like all x will be cancelled, x 4 times, x 3 times, x 1. Next 4 power 4 is 256 by 2 cube is 8, 8 4 is 32. 32 it will be divided by, and the answer is 8. That's it. Well, here is our last question in our topic. Yeah, this is a bit interesting one. At constant temperature, 80% of AB dissociates into A2 and B2, then equilibrium constant for the equation. Okay, the equation is clear here. So this, they are saying 80%. Meanwhile, 80% is disappearing. So initially, if we take, it's like okay, let's take 2 and 0 0, and at the equilibrium at time equals to 1 and time equal to 0. Meanwhile, at equilibrium, okay, time equal 1 at equilibrium, 2 minus 2x, because here 2 is there, so I'm writing 2x. Here the x is formed, and we know that the x value is 80%, means 0.8, right? So 2 minus 2 into x is 0.8 as it given. So 2 minus 0.8 into 2 is 1.6, and here 0.8 and 0.8, and here equals to 0.4. 0.8 into 0.8. Now that we are writing Kc, so Kc equals to product 0.8 into 0.8 by uh, AB. Here 2 is the exponential form, so whole square for this, 0.4 into 0.4, so 2 is 2, so the Kc for the reaction is 4. That's it, we are completed with this topic. Well, let's meet with another topic. Please like, share, and subscribe. I'm a new YouTuber. I started my career now itself. Please support me. I'll help you with the more videos. Please help with me sharing this video. Thank you.